Great, thanks. Hi, everybody. Thanks for coming to this session. My name is Michele Adams. I'm a civil engineer with Meliora Design, and I'm going to talk about obstacles to green infrastructure. And please, along the way, chime in with thoughts and opinions and suggestions and so on. So I'm going to talk about, you know, we all are familiar with this idea of the whole idea of green infrastructures. Our built environments are going to work like forests. Even as we build things, we're going to maintain our natural balance of water with our 45 plus or minus inches of rain and create these spongy landscapes that hold our water. Nothing works like a tree for that. So our engineering is informed by nature. And by now, we're all familiar, I would assume, with all the kinds of best management practices we can do. We're rain gardened to death. We all know about porous pavement and reusing water in cisterns, like out at Stroud, and stormwater tree trenches, and on and on. We know these things are out there. We know they work. And a lot of us here are very familiar, some are very familiar with the practices of protecting things and building things, whether it's riparian forested buffers or restoring meadows, but changes in landscape and protection of natural features that have a huge impact on the amount of runoff and our water quality. We know these things work too. So why aren't we doing more of this? Why aren't we seeing this in our development projects? And I'm in practice as a civil engineer, and in our firm, most of our work is related to sustainability projects. We do a lot of land development, but with a sustainable, like the Stroud Research Center, projects for universities, some commercial land development, but we're always working to do better stormwater, better land development. And we've learned that there are a lot of real challenges that I'm sure many of you have encountered that come down to local codes and zoning and ordinances, and that's a big one. Especially the stormwater ordinances. The permits and the timelines for approvals, because when you're working on a development project, whether you're Toll Brothers or the University of Pennsylvania, you have a time frame and a budget, and you have financing, and you have to move your project forward, and you can't get delayed in your approval process, which goes back to codes and the stormwater ordinance. And then once we get a good project design, do we have experience in the construction community on how to build things and build them properly, and then how to take care of them. And then, of course, the aesthetic expectations. What are things going to look like? So I'm going to share some of these obstacles we've encountered and some things we've found that help in the context of projects. This first project I'm going to share with you, just this image, isn't built yet. It's an eco-village that's scheduled to be built down in London Grove, Chester County, starting this year. And it's an eco-village which is meant to be a community-based way of living. So if you look carefully at this plan, it might look like townhouses, but in fact these are pods, these are groves of housing together, and these are alternative housing units meant for different age and economic groups, young couples, people, empty nesters, young families, so some have many bedrooms, some have one bedroom, all meant to use a community house for things like special events, have meals together once a week, have a community garden with a very ecological component. So it's community living with these greens between the clusters of groves, solar panels over the porous paving parking lot. If you notice, there's no driveways, there's no garages, you can't drive your car to your house, you have to park in the parking lots, maybe under the solar units, and walk to your homes. They'll have a community natural swimming pool. They wanted to have a natural wastewater system, not unlike what Stroud put in, but the things that come up in a project like this, the township was very good in working with the team, with the property owners, to develop a zoning overlay that would let them do many of these things. Because when you want to do something like this, it breaks all the rules in a township ordinance in terms of setbacks, parcel sizes, where you park. So the township was very proactive, and we got through zoning, and that was all good. But then when we got to actual land development, the traditional issues with no streets, where do you put the water and sewer lines? How does the fire truck get in there? How do they get out? How does the trash truck get in and out? How do you have accessible pathways? Those kinds of components. If you put the solar over your parking lot, what are the rules for that? And so it's all doable, but it takes time, and it takes time in the design process, and it takes time with your attorneys to work through those issues with the development. And most developers aren't willing to spend that time and money to get to something like that. So obstacles in our codes. Another thing is this community wanted to have the wastewater system. The local municipal authority had just built giant spray fields and a treatment system, which the spray fields are great, but they had lost a lot of their customers with the downturn in the economic in 2007. A lot of developments that were supposed to be built weren't built, and so they had all this capacity in their wastewater system. So they were very anxious to have a live customer who would buy sewer service. So they didn't want an on-site sewer system at this facility. So that was a huge cost and a huge expense, and then running easements through the property for all the utilities. So these are the kinds of things that come up for real projects when you want to do something different and more ecological. This one's about to be built this summer, and they're still selling units if anybody is looking for a place to live. When things like this come up, not just the eco-village, but the obstacles in your ordinances, I don't know how many here are familiar with the EPA SCORECARD. Is anybody familiar with this tool? Some of you, okay. This is a very good tool. It's a rating system put together by EPA, and it's not perfect, but it walks municipalities through their ordinances, everything from what are they protecting or not protecting, to their actual codes for how we build streets, how we build lots. It's a good rating system that lets you rate where your municipality is now, and then make changes in your ordinances and come back and re-rate and see how you're doing. It's a very good working tool. So that's something that can help with the municipal ordinances. The big one we see is the stormwater ordinance, and I'm going to have a few technical slides, not too many, I promise. But stormwater is a big issue with our ordinances at the municipal level, and I think, in my experience, it's the municipal ordinances that are getting in the way of better stormwater management, even in townships that are trying to do the right thing. I see a lot of people nodding their heads because they've been through this, they know this. Even in townships where we're requiring volume control, we still have antiquated requirements for peak flow rates. And the way engineers calculate those peak flow rates is getting in our way. Now, everybody knows that if it rains really hard, the water's going to run off really fast. Common sense, potentially. But the way engineers are calculating that, we're assuming the very worst rainfall intensity, inches per hour, how fast it's raining. And we use that to say what's safe before development. So we assume the worst condition, come up with a very high flow rate before development when it's in woods or meadow, and then we say that's what our streams and our channels can handle, and that's way more water than our streams and channels can handle. Other things, we don't get credit for better landscape practices, and a lot of places existing impervious is grandfathered. If it's already built out, you don't have to make it better. So going through some of these, we're all familiar with the idea that most of the rainfall happens in the small storms, both in terms of rate and frequency, and we've recently updated this. Come on, screen. Huh. Okay, well, we've recently updated this with more recent data from the, come on, screen. Just touch it.
Just touch the screen.
Just touch it. There it goes. Okay. So this curve right here is from 1950 to 2013 rainfall data at the Philadelphia airport. And what we're showing here is this is percent frequency of rainfall events, and this is total rainfall depth. So what this is showing is 95% of the time, rainfall events are about 1 point inch or less. It's interesting. And yeah. 81% it's 1 inch or less from our Philadelphia. So these are our small rainfall events that we're all familiar with. And those extreme events, you can see how far they go. And if you want to go to the next one, Clay, thank you. But here's the problem. When we talk about these big rainfall events, 100-year, 25, 2-year, and engineers calculate flow rates, you say, okay, 100 years, 8-inch storm, but how does that rain occur? And we use an artificial rainfall distribution that basically assumes most of the rain happens in 1 hour. So it drizzles, 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 rains like the dickens, and drizzles. It doesn't really happen like that when it rains. Thank you. So, and these are my most technical slides, so bear with me. This is a slide looking at some hurricanes in that time of period. Hurricane Floyd, there's Irene, there's a couple others. And we see a couple things. This is the rainfall depth, and this is the rainfall intensity in inches per hour. And if you hit it again, this is what engineers use to design with. So this would be about a 25-year storm. We'd get about 6 inches of rain. And you can see these hurricanes are in that ballpark of rain. That's a 25-year event. You can see we had 4 of them in the time period. But anyways, if you hit it again. But when you look at the design storm, it's raining at 2.67 inches per hour. That's coming down really fast, and so that's a very high flow rate. It never really rains that fast in the hurricanes that we see. So what we estimate is safe in terms of flow rate isn't safe at all. We're grossly overestimating how much flow can come off. We do get rainfall intensities that high, but the maximum in record is associated with something more like a 2-year storm. And that's, if you think about summer thunderstorms, that's when you see your big rainfall intensity, not as much volume. So this, if you don't mind hitting it, Clay. Yeah, and going on to the next one. And so that's why we're letting too much out. Keep going to the next one, and we see our stream channels eroded. We're not being safe with our flow rates either. It's not just volume, but our flow rates for the big storms are too much. We'll go to the next one. And this has consequences for how we design. And as someone who's trying to do green infrastructure, it kills me when it has a bad impact on our projects. So this is a project at the Mann Music Center where we had 2 big bioretention areas, but the lower one, we were required to adjust it to design for these large storms in a flow rate that'll never happen. And so the way we did that is it got pushed down to look more like a basin. So the upper bioretention area is lovely, and it looks lovely, and it's growing in, but the lower one was pushed down. And so we see the side slopes eroding, we see sediment, you can see the structures. It doesn't have nearly the same aesthetic, and it'll never fill up with water. It'll never. You'll never see that thing filled up. It's the engineering calculations are forcing us into designs. But we see projects doing this to get through the permitting process. Because if that's what's in your rules and you got to get a permit, you're going to do that. And so that's an obstacle we see a lot of. If you don't mind going to the next one.
Excuse me, Michele, is that
Yeah.
in the city of Philadelphia?
That's at the Mann Music Center. You can see both of those in the city of Philadelphia. I'm sorry. Yeah, at the Mann Music Center in Fairmount Park.
Could you just say again what it was about the one that's not performing? That the code said one thing and it's not really performing.
The code, well, it's performing. It's holding volume, but the code said we had it designed for these very high flow rates that never happen in reality. And the engineering methodology, the way engineers calculate that, forces a big basin. And so we got a bigger basin by pushing it deeper. We see that all the time. And then the sides are too steep. And then in construction, it eroded on the sides, and the plants didn't do as well. All those things we see over and over again in actual installations are coming out of our engineering codes, I think. Oh, yeah, Shadi.
Then the Mann Music Center probably comes to you and says, come back, this isn't working, or fix
This is
it.
ugly.
Yeah, this is
ugly.
So how do you handle that? What do you do?
Well, we don't have a way for fixing having to make it deeper. We can come back and make the plants a little better. We can do plants that grow higher, so you hide the ugly sides. But if you don't mind going back one more, Clay, sorry. Thanks for jumping in and being a tech assistant. If you can see the difference between that and that at the same project site, and the client wants this, putting in bigger plants is going to make that harder to maintain, not the same aesthetic. And this is right on the drive as you're driving into the Mann, so it's very visible. And they want it to be a nice landscape. So this is a real challenge. If you're trying to stay in business as a designer, you don't want your projects to be ugly. You won't get more work.
So an alternative to that one, not that we shouldn't push back against the silly codes, but
Right.
an alternative to that is it would have to have a bigger footprint.
Yes.
So you didn't get the storage by having a deeper system.
Thank you, Joe. And if we made the footprint bigger, this is at the bottom of an existing parking lot. It was a retrofit. They would lose more parking. They could not lose more parking. So these are that's a great question. These are the real things you bump up against in real projects. So, thanks, Clay. So, and the other part is when we do all this volume management through our BMPs, we don't give credit to that volume management when we're calculating our flow rates. You calculate your flow rates as if there is almost no volume management. They're kind of separate universes. If you don't mind going to the next one. There are ways to overcome this. The state of Maryland has done a good job. They came up with a method to work within the methodologies that engineers are used to, the cover complex method, and they have lookup charts, and as you have your percent impervious and you start managing your runoff volume, you get to adjust your curve number on these lookup tables. So even the engineers don't have to do the math, they can use lookup tables. And the goal, that's important, the goal is to get to a curve number which represents your land use that's closer to forest in good condition. And if you get to forest in good condition, you're good. You don't have to do a lot of your flow rate calculations, your peak flow rate mitigation, because you've managed your volume well. And they've also brought the storm down. They don't usually take it up to the 25, 50, 100-year storms. It's not perfect, but it's helping.
Any chance that this might come to Pennsylvania?
Well, hopefully. You know, there's this committee working to update the manual by volunteer methods, and Dominic Rocco at DEP has been involved, and we're proposing this. We're proposing that Pennsylvania bring it into the manual. It would still need to come into the municipal codes, because as a designer, when you're working on a project and you go get your permits, you can get a permit from DEP, not too hard, I don't want to offend anybody. Getting your municipal permits is hard. So you're gonna defer to the municipal rules. So we have to change municipal ordinances. That's a great question. Yeah, Wes?
And would you go so far as to say that because of this perverse peaking methodology and set of requirements, it actually starts making the whole design, including achieving the volume control, that much more difficult, maybe even absurd, certainly more expensive, and so it really perverts the whole design process.
Exactly, Wes, because you know this exactly. It perverts the design process, and you end up spending time and money and construction costs on things that aren't needed, that aren't ever going to do anything. The Eco Village project I showed you at the first one, we proposed using this alternative methodology. DEP was good with it. DEP said, yeah, let's give it a try. The municipality said, we're really worried, we don't want to be liable, we don't think so. What we did in our office is we did the modeling and we ran actual hurricanes. We said, okay, here's a design storm, but here's what would happen if Floyd happened again, if we designed it the way your code said. And we showed it would actually make things worse. And the municipal engineer said, Uncle, okay, do it your way, can't be worse. But it's hard for engineers and owners to do that. There's no money to do that. So another important thing, our landscape practices. In our engineering methodology, we don't give them enough credit, and we know they work, but it isn't represented when you do the math to get your permits. We treat them all the same, and if you don't mind going to the next one. And we don't take into account the fact that the uncompacted soils and woods and good landscapes absorb water so well, and our golf courses and our lawns are almost as compact as concrete. They don't absorb water. So don't mind going to the next one, Clay. An example I'll share with you that is down at the University of Pennsylvania. This is an urban example. This is the new plaza Penn built between the Palestra and their stadium. It used to be all impervious and tennis courts, and they built a whole new plaza there. It's quite beautiful. And it has to follow the City of Philadelphia stormwater requirements, which are very rigorous and very good. If you don't mind going to the next one. So it had a number of goals. This is actually a sites pilot project. If anyone's familiar with sites, it's very much like LEED. It's a rating system, but for the landscape. It's a great resource, and it also has a lot of requirements about site protection and site restoration and understanding your resources. So sites is a great tool. This is a pilot project, if you don't mind going to the next one. So a little bit of history on the site. It's in Philly. It had been row houses before it became tennis courts by the civics, by the stadium and the Palestra. There were the tennis courts right there. It's right near the Schuylkill River. You've got this landscape, the train tracks, and the Schuylkill River. It's on about 30 to 40 feet of rubble and urban fill. So when we looked underneath the tennis courts and we saw 40 feet of imploded buildings, and you could literally stand there with a fire hose and water would go away, we said this is not a place to infiltrate because the whole thing will start settling if we start putting a lot of water here. So the whole system is lined. It does not infiltrate. There is a liner and one pipe out underneath. And if you don't mind, there's what we saw. There were some trees we wanted to protect, and this is urban environments. This is what you see when you dig under the ground. If you don't mind, go to the next one. So the stormwater goals were to make a sponge-like system and to hold water and reuse it for irrigation. So we have a number of components. If you don't mind, go to the next one. So here's the system. Here's the new green. Here's the rain garden and some tree trenches. This is the track over here. This is the gym and the buildings, and the street is out here. So we have a system that collects water from the impervious surfaces all around it in the buildings and takes it into the soil and distributes it in the soil. And there was no soil, so it's a made soil. It's sand and compost. It's completely artificially constructed. And they added organic components, fungal components, so it's a made engineered soil because you don't want to bring in topsoil from someplace else because you're taking that resource from someplace else. And there's a cistern for the water to be reused and recirculated, if you don't mind that. And so this is just showing in 3D the plan a little better with the distribution system and the cistern. And this is just taking of the different components as you go down to the layers. And if you don't mind going one more. The rain garden's at the top. The rain garden, interestingly, as beautiful as it is and as photographed as it is, does almost nothing in terms of meeting regulatory requirements. It gets almost no stormwater credit in the city of Philadelphia. We had a very hard time getting through our permitting process, and Penn, as a university, had a schedule. This had to be open for graduation. They'd had some similar experiences on other projects, and so you have a client as good as Penn who wants to do the right thing, but they have a project they have to open on time. So you get to a place where you want to have a beautiful landscape, but you end up doing underground storage tanks and things like that to get your permits. This is the reality. This is what gets in the way of good green infrastructure. And there's just another shot. But this landscape, and there's tree trenches, yeah, that's fine. You can go all through this, is incredibly absorbent. And so it's been in place for a little over a year now, and it's got a liner underneath of it and one pipe that leaves it. And Penn is monitoring the system. They're monitoring the soil, they're monitoring the discharge, they're monitoring the rainfall. And what they've found is in an entire year, there's been no discharge from this site because the only time there was a discharge was when the irrigation system was broken and the pumps were on. But it's holding water, pumping water around, and it's this giant sponge that evaporates. There's no discharge. It's grossly overperforming the calculations for the permit, but that evaporation really gets no credit in getting your permit. And so until we close that gap of how do you quantify the benefits of something green like this when you're doing your engineering calculations and getting a permit, you don't see enough of this. So this is another obstacle. I see a lot of heads nodding. I get the feeling you've all encountered this before. There's a little diagram showing the made soils, the stone bed, the bed underneath. And we use something called a SMARTDRAIN system. If you don't mind going to the next one, Clay. This is the cistern that captures water for the reuse for the irrigation. Oh, that's another issue with cisterns. We can use them for irrigation. Even when we use them for irrigation, they have to be treated to potable standards. So there's a cost for collection and treatment and disinfection before you irrigate. And then if we wanted to drink our water, unless you're an individual home, current regulations really preclude that, and that's something Stroud has encountered in wanting to drink, and you guys are working, I believe, Susan, to try and overcome some obstacles with that. But this is a SMARTDRAIN. This is the SMARTDRAIN system. These are plastic belts that work by capillary action. And so what they do is they pull the water out of the soil, but very, very, very slowly. So we've found this to be a good tool at having systems that drain, but drain very, very slowly. But this was something new to the water department, so getting that through the agencies, getting that accepted and approved is another hurdle when you want to use new technologies. If you go to the next slide, it shows the soils. This is how the SMARTDRAIN system works. We've used them on a lot of systems now.
Is
They
it
work
an
very
osmotic
well.
technology?
It's capillary action. This is a plastic plate, and underneath are all these little grooves. And the grooves, it's like a plastic strip. The grooves pull the water by capillary action, so they can really be essentially flat. It was developed for golf courses and athletic fields. But in doing that, you are able to discharge, but very, very slowly. It's very powerful that way. If you go to the next slide. This just shows the drainage layers and the soil layers for the made soil as this landscape was created. If you don't mind going to the next. And there it is when it was done. So it's working beautifully. It's become a beautiful place. Even with a lawn, it's a very absorbent lawn because of the nature of those made soils. It's not like a traditional lawn. And it's doing a lot for stormwater, but Penn to date hasn't gotten credit. And we didn't get credit in the permitting. Hopefully through monitoring, the campus will get more credit.
A question about mowing that lawn and whether that increases compaction. What did you do about that?
It is a mowed lawn. The soil scientist, who's Tim Kroll, who you probably know, has a gradation of, it's mostly sand particles with organic. And the sand is graded so that it has a structural capacity without getting compacted on these made kind of when you need a lawn, because sometimes you need a lawn. So that's a good question. Okay.
Question, I guess, do you know the percentage of sand, topsoil?
It's mostly sand and organic, and I don't, but Tim has a lot of that available and
That's what we were
published.
seeing, some of the 85% sand
It's
and
high sand.
13% on the top, or on the compost, and then 2%
Yeah.
soil.
And very,
Volatile soil.
yeah, and different gradations of sand. And actually, there's another source. The city of Seattle has done a lot of research through Washington University, and all their specifications are available on their webpage, and research from Washington University where they've looked at different gradations to make lawn that's absorbent and drains. And also the same soils for your bioretention areas.
Over time, that organic component is going to be slowly deteriorated away bacteriologically, or what's going to happen in 25 years, or however long that takes?
Well, that's a really interesting question, and you're a little bit outside my area of expertise here, but with the organic material, there was also a fungal and a community soil component of living organisms that were dosed into this system, not just initially, but to with the irrigation to encourage the root system to expand and the fungal community. So it's intentionally encouraging a fungal community that connects root systems and root systems for grass that go much deeper than usual. You know, grass is usually very shallow root systems, but with these systems, there's another plaza like this at Penn that we were not involved with, but Tim was, and they're seeing the root systems will grow in response to the good drainage and the fungal community, creating those healthy root systems. So.
With that grass, I could do it with a hand mower, it's so small. I mean, you know, with a power mower, not a big tractor.
Yeah, it's, you know.
And I would recommend that to keep the compaction going.
So do we need new criteria for when we put in lawns and what they should be like and how they should be maintained? And do we need to be training landscape maintenance folks to do this, as well as contractors to install it? So we make those changes.
Michele, I thought Philly had updated their zoning pretty recently to incorporate green infrastructure.
They have. Philly's updated, and they have new requirements that no matter what you build, you have to manage your stormwater volume. You're not grandfathered. They have some of the most progressive, if not the most progressive, requirements in the country, and they're working very hard.
Predate the adoption of that?
This is in response. What comes up is the engineering methodologies. So Philly has new rules, but the engineering methodologies and techniques for doing the calculations are stuck in the 60s. And merging the two is where we get in trouble. That's why we don't see more green infrastructure, I think.
What is the limitation on public use of the green square? Are
It's
students allowed to
open.
use it freely?
Yeah, it's a student plaza. It's open. You can go.
So they can get down into it and even into the retention areas, the rain garden
Well, they
areas?
can sit. I mean, you'll see
There's like
people
a step
sitting.
work, yeah. I saw
Yeah,
that.
people can walk. You'll see. I didn't put any pictures with people. This was before but we do have some from the opening where people are just all over it, and it's designed and meant to be walked
Meant to
on,
be.
used, sat on. These walls are all for people to sit on. It's meant for events like graduation. It's meant to be used. It's a park space. Yeah, it's public. One last thing relating to stormwater ordinances, this idea of existing conditions, and this is a diagram from a project Villanova University's talking to Radnor Township about. Radnor has very extensive stormwater requirements, pretty good requirements, but you're grandfathered. If you have a parking lot and you're turning it into new dorms, this is the area of the big parking lots at Villanova along Route 30, and they want to build a new project. You don't have to manage that volume very much, just very nominally for groundwater recharge. And so what the community and the Riverkeeper has been very involved in this are asking, or saying, Radnor, get rid of this grandfathering for existing conditions, make them manage volume, not just peak grades, because we don't need more big detention facilities in the Darby, we need volume management. So that's a real issue with ordinances. So I'm going to jump over to issues related to construction and maintenance. And this is a project that was built a few years back in 2 phases down near the University of Pennsylvania. This is the RALSTON Center on Chestnut Street. It's a community organization for an aging population. They provide social services for aging population. And so because they're very tuned into the community and ecological issues, they retrofit their parking lot to put some rain gardens here. And if you don't mind going to the next one. And those worked pretty well. So this is a retrofit for an existing parking lot. They were changing their landscape to make it absorb the water. This worked very well. It continues to work, but the thing we see is that the maintenance crews put too much mulch in, and they never take the old mulch out. And so the mulch piles up, and so the drainage, and we see this a lot. So training maintenance crews that the mulch needs to come out, the old mulch, before, and the type of mulch you put in, so the water can actually get into these systems. They tend to dam them off with too much mulch. And there it is growing in. They did a second project, though, if you don't mind hitting it again, over in the front of their facility. They got all this building and area with a rain garden that they retrofit out front. And while they were putting the rain garden in, 2 things happened. It was a contractor that wasn't very experienced at green infrastructure, and 2, Hurricane Irene happened, and then Tropical Storm Lee. So they didn't do a very good job with their E&S measures. And keeping their site protected. So they put their rain garden in, and this rain garden actually has a little stone bed under it, and there's a stormwater inlet connection right there that serves as an overflow. What happened by not having good construction practices and not keeping their erosion sediment control measures in, they had too much fine sediment wash into the rain garden, and it formed a lens a couple inches down. And so you could go out to this puddle and poke a stick through it, and it would gurgle and bubble, and the water would go down. There was an impermeable lens that formed. We see that a lot when things aren't built right. The way this was fixed is to come back, and if you don't, this is when it wasn't doing so well. We came back, and we had them dig it all out, take that material and mix it with more sand, and when they restored it, then it came back and it's working fine. But that was a construction problem and an E&S problem. We see a lot of that. Property owners don't like to pay for their engineers to be out at the site to do inspection during construction. What they like to do once they have their permits is say, thank you, have a nice day, goodbye. But if nobody's out there making sure the contractor's building things properly, they don't get built properly. So we need more inspection when green infrastructure, and we need design professionals out there inspecting when these things are being built. If nobody's watching, you can't always count on the contractor to build it right. You can go to the next one. Another similar one that had similar problems is a new fire engine. This is actually the fire station. It has a green roof on top of it. That's why it's green. The parking lot, it has 2 buyer retention areas, lots of meadow. This is a new fire engine that was built in Philadelphia. But if you don't mind going to the next one, They didn't quite get the construction right. Many trades coming in and out. This is a publicly owned building going through a public building process, Department of Public Properties, which has ways of doing things that are not contract friendly to alternative designs, whether it's a green building or a green site. Contractors didn't get the grading right, and so what was supposed to be grading and densely planted was not. That area eroded and runoff came off and went right into the rain gardens. Oops, yeah. Rain gardens and filled them up with sediment. So again, you get a lens, keeping your water from draining. So these are construction problems because nobody was out there watching during construction. And if you don't mind going to the next one, compaction occurred during parts of construction. And getting the specifications right, the soil, they finally did get the soil right. We rejected the soil mix 7 times before the contractor got it right because it's something different. They're not used to it. And you can see the guy working here, it's kind of a mess. He's got his equipment right in there and there's stuff everywhere. The end result is that it wasn't working well and it grew in too densely and a lot of weeds grew in without maintenance, and the firemen are very, very unhappy because the firemen take great pride in their facility. They get rated and ranked by how good their facility looks. They wash and shine their trucks. They love their building, but it's important to them that their landscape be well addressed. So the City of Philadelphia Water Department is now intervening to go out and work, now that the snows have cleared, to help the fire department fix this and then learn how to maintain it. But that gap has led to unhappy firemen and an ugly site, an ugly rain garden out front. So that one's not fixed yet. So, yeah, there it is.
Would they have another option of just making underground storage instead of that?
Well, they could have,
Yes.
but then that's not very green. Then all you have is, it's hidden. It's out of sight, out of mind, it is expensive.
It's not out of the maintenance budget, though, that's the...
Not out of the, well,
Not-
it is.
not as much.
Not as much, but if we're talking about changing our landscapes and creating a green city in Philadelphia and elsewhere with our alternative practices, we don't want to just bury things and hide them. We want the landscape to be credited and we want it to be built right so it works. We're going to get back to that sponge landscape. So if you don't mind going to one more, Clay, I don't know how we are on time. This is one that was done right. It happens to be a Riverkeeper project. This is out, if you see if this will work, so you can sit down. I'm sorry. No, it doesn't seem to work. This is over in Haddon Township, New Jersey. This was led by John Leisted of the Riverkeeper. And it gets about almost an acre of municipal roads taken onto rain gardens built at a local school that was having erosion problems in the woods behind it. And so here's I think this animates if you hit it. So the water coming down the roads and from the parking lot all comes in, and this is, if you hit it, it should where the rain gardens were created. And this is Sadler's Woods, a really remarkable stand of old growth woods in Haddonfield, New Jersey, that has very steep banks that were eroding, not unlike Krabby Creek and places like that. So the idea was to capture the water and protect the woods and manage the community water. Yeah, and then it goes into the woods. So if you hit this should animate. This just shows you what's happening. Oops, no, it didn't animate, but that's okay. Keep going. So we did careful soils tests for infiltration to see what we had. Wasn't all great infiltration everywhere, so creating an absorbent landscape was important. Yeah, some was good, some was so-so. Pretty high clay in parts of the schools. The soils were moved around. This one animates. So this shows how the water comes through into a series of rain gardens, swales, berms, and rain gardens before it overflows. If you hit the button, it should, yeah, if you get, yeah, the water runs through. So this is taking a pretty big area and a lot of stormwater, and that's all good, but the trick was getting it built right. And let me get to those slides, because on this one, we had a very good contractor called Think Green. They actually did much of the landscape work at Stroud as well, if you keep going. We have meadow grasses, very simple design, so the maintenance people know how to take care of them. So it's one design, they can tell what's a weed, what's not a weed, and they can mow it. Only 5 species of perennials, keeping it very simple, we find helps a lot in places like schools and public properties. We can go on to the next one. Using this takes the water off of the street, which is full of sediment, and uses some stones with a little sump right here so the gravel and the pollutants can settle out before it goes into the swale. But you can also sit and climb on that when it's not raining. But if we get to but the key was, when this was built, here's the vegetated swales going in. We had a very good contractor who knew how to phase his work and who knew how to use the materials. So the materials we used to stabilize the swales and the channels, he knew how those should be placed and installed. This firm was founded by 2 landscape architects that started a construction firm, so they understand both ends. Putting the stones in, getting your grading right, so your water works the way it's supposed to in terms of water levels and flows, and that's what it looked like when it grew in. But if we go to and this is the level spreader. This is at the very end, the level spreader that disperses the water into the woods without a point discharge to cause erosion. And they were in the middle of construction and a 10-year storm hit, not unlike the other site at RALSTON House that had problems. Because this is reality. You're in the middle of working and a big storm hits. And we had massive flows run through the site the day they were supposed to do much of the planting. But if you go to the next one, Clay, there's actually, I didn't put the video in, but we had huge flows rushing through, but nothing eroded, nothing washed away. No sediment got deposited because the contractor knew what to do. We had it on our drawings, and we had a knowledgeable contractor. This is what happened as they were planting, and this is just rushing. You could almost run a little raft through there. And part of that was how they staged their construction. They worked from the back forward, and as they stabilized things, they brought their organic material in, and then they worked forward so they weren't compacting their organic material. So very careful staging of every component, of not just knowing how they put the materials in, but how they stage it. We usually put that on our drawings. Contractors don't always follow it, and most firms don't, there's Princeton Hydro, Biohabitats, will put it on their drawings, but a lot of firms don't document that level of detail for construction, so things don't get built right. If you go one more, so you can see he's working his way forward with the planting, with the mulching, and then the volunteers came in, of course, and one more, just a finished shot. This is actually John Neisted, from the Riverkeeper's son, walking across the little berms. And then the last one I'll share with you, if you keep going, yeah, more post shot. These are the shots everybody wants, of course. The last one I'll share with you, I know some of you are familiar with this, was the Trout Unlimited lead detention basin retrofit in East Whiteland. This goes back to 2006 when the basin was retrofit from a mowed detention basin to a stormwater basin that now everybody forgets that it used to look like this not that long ago. And this went through a careful process of installation, creating the basin so the meanders occur, fluffing up the soils, the twig plantings of willows that that have grown in quite well. But we use the small plugs to make it cost effective for this kind of planting. But if you go to the next slide, the critical component was the maintenance stage as it was establishing. And I know the TU guys talk about the site assessment and the weeding for the first 3 years until the native plants could establish. It could look quite messy until it got established, until the township learned what they had. But here we are, summer 2010. This is my friend Tavis Dockwiller, the landscape architect out there in the basin, now waving now that it's a meadow. But here's where it got interesting. We got a call about then from the township, from East Whiteland, saying, "What the heck did you guys tell us this would make life easier? You said we'd have to mow it twice a year and we'd save all this money. Our guys are spending hours out there. So we went out, and it turned out the maintenance crews were so enamored of the flowers that had come in that they were carefully clipping as if it were Longwood Gardens. We said, mow it all down, it will come back, it's okay, mow it. It's meant to be mowed. And they said, okay. Twice a year they mow it, and then the last slide. But that managing those expectations and the long-term maintenance is critical. The landscape architect did a simplified first-year, second-year long-term maintenance plans. We put these on 11 by 17 sheets and we laminate them So facilities like this know what to do now. And then the last one is just, and things like the mowed edge, allowing a mowed edge so that there's a level of comfort between the wild areas and the natural areas. Now that it's like this, the community's pretty much forgotten it ever was mowed. It's accepted. So with that, I'll wrap it up if there's questions. But these are the things we see in the obstacles of getting to all these great BMPs that we talk about. Why don't we see more of them? Wes and I worked together back in 1983 on one of the first porous parking lots at Great Valley Corporate Center, and that's 30 years now, and I thought the whole world would have changed by now. So these are, yeah.
Could you talk a little bit about your thoughts on Act 167s? And because I get the impression, I'm in Berks County, I get the impression that it varies by county and area. Do Act 167s, because in Berks County, that's where our municipalities are getting their stormwater ordinances, and we decide to encourage joint regionalization and planning. Do these really need to go back and be examined?
I think they need to close the peak rate calculation issue. That's where I see we're continuing to propagate. It's not that we're not worried about floods. We have to worry about flooding, but it's in our engineering methodologies that we need to close that gap. So we might be able to close it in the context of some of the existing 167 ordinances if we could alter the methodologies like Maryland has. If we gave engineers different tools, and we have to make those tools available to the municipalities and their design engineers. They have to be accepted in the engineering community. So, yeah, but yeah, if we don't fix it, we're propagating the problem. Okay.
How do we sort out the contractors that know what they're doing? And in Swale, you said that contractor, or assuming that it's by free bid, you have to take the lowest bid. How can we? Is there some set of documents that we can use to instruct them on how to do it the right way?
Well, we document it in our drawings. Like the fire engine project that has problems it was well documented, but it had to go to low bid. And so what we're now recommending to clients, even public clients, is that they have qualifying criteria for their contractors. So it might be the low bid, but you also have to show you've done 3 of these, or you've taken courses from NOFA on organic landscape management. You have to start to show your qualifications. We're finding that's helping. That's helping places like Penn, which doesn't have to be public bid. You know, they pre-qualify the contractors, or they have standards the contractors have to meet before they can even bid. So that's one way, yeah. Chadi.
Michele, could you explain the aesthetic expectations, what you mean by that?
That goes, one, not to just problems with maintenance and weeds coming in and people are unhappy because it's ugly, but even we're still seeing people not used to the idea of meadows, not used to the idea of more naturalized plantings. They like a lot of hardwood mulch. They like we still hear that from our more commercial type clients and residential type clients. It's what they're used to seeing and what they're used to taking care of. So that aesthetic expectation, they're not used to something that looks different, even a mulch that looks different. They like it dyed, they like it big. You know, when you try to go to a leaf compost mulch, that's a different look. And especially commercial properties worry that people will think it's not properly cared for, that the maintenance isn't there. So, yeah.
Michele, have you heard of anybody that's done any work to evaluate like mosquito population? Because that's one of the biggest objections most residents will have. You're going to build a mosquito pit and you're going to get West Nile virus. So,
and you
has anybody actually done the sampling that's needed? Any health departments or any university?
I know there's research. I can't quote it. A lot of it has to do with the time frame. And Joe, jump in because I know this is some of your expertise.
So the Society of Wetland Scientists was, very concerned with that because creating wetlands in some of these facilities was unrealistically being blamed for pestilential populations of mosquitoes, and it's not a fair criticism. So they did a white paper. So if you go to their website, there's a white paper on that does a good job of explaining what the real risks are and what the appropriate kind of management techniques are. And in a lot of these systems, if either you're perking the water, like the worst case scenario is if you bring water in for 2 or 3 days and then it dewaters, because that's long enough to have the egg laying and the hatching. But if you have either a permanent water source, even if it's a small permanent water source, or if the water doesn't have more than a couple of days of surface inundation, either of those will eliminate the risk or dramatically reduce the risk.
Is that white paper written at a level that municipal folks could understand it?
Yeah, yeah. I mean, that was the intent, was to help regulators and resource folks and residents, you know, of areas to understand what the real risk is.
Joe, was that related to just wetland mitigation banking? Or
Not to banking,
Okay.
but to wetland restoration, and
Okay.
it also touches on a lot of the stormwater BMPs.
Did you want to say something, Wes?
Yeah, responding on the 167 issue, Chester County has a new model 167, Lancaster County. I'm not sure about Montgomery or Berks. You may have.
Ours are a little bit old.
In any case, they've made huge steps forward, and they're now requiring volume control and whatnot. Major steps forward, but as Michele has said, we're still hung up on these horrifying P grades. In addition to that, our worry about some of these models is that they do not go into site design. They do not promote low-impact development, green infrastructure, and the full understanding of the site, as we now realize the concept of stormwater management must first come to terms with the site and its constraints and opportunities. And so we've been working with NIFWIF and Chesapeake Bay people in trying to integrate all of those elements, which are really dealt with in the existing 2006 BMP manual, believe it or not. They're in there, and trying to promote concepts of preventing as much stormwater generation as possible, and then green infrastructure mitigation. And so if you're interested, holler. And we're working with a couple of municipalities now to try to make that happen, at least within Pennsylvania's Bay drainage.
Better codes.
Highest level, a higher level of performance.
Better codes,
I do
yeah.
want to address the West Nile
Yeah.
question. In Chester County, we met with our health department just a few weeks ago because there is a concern. They're saying, the health department, that the areas that they have found that have been retrofitted or gone back to a more natural-like state are more attractive to the species that will carry West Nile virus. And they are recommending that basins be mowed.
Going
I know.
backwards.
So we are kind of like, you know, at a,
What do you
now,
do?
and they're doing that from actually going out and surveying and, you know, sampling and coming back and finding. So the
I've heard that
easiest,
in Bucks too.
yeah. So the easiest thing, I think the mutual compromise, because they understand the concept, they say, yeah, we don't like the mode appearance either, but hey, this is what we're finding. So their recommendation to us was to make sure that when you go back in and you do naturalize, that any wet areas, it would be best if you put in, you know, the mosquito dunks and some type of insecticide, because you are going to still have to address the concerns of those individuals who, whether or not they even know that in a naturalized basin this is there's more conducive, but they see that standing water and the first thing they think, of course, we all know it's mosquitoes, but they're saying that it would be best if when we talk to them about naturalizing their basins, we, as Conservation District, also recommend that the dunks be used.
Yeah. Thanks, Shai. Owen, you have.
Well, I guess one of the things that gives me a sense of despair is the anthropogenic immense, I mean, this is a classic example of people bringing in an invasive species because of the transportation system, and then it's like we as human beings have created this industrial society without thinking about what a forest is or a waterway or anything.
How they work.
And then all of these different dimensions of it are even worse in terms of not thinking of how do we get in balance?
But it
And I
really
think,
goes back to
my
systems
answer to
thinking, yeah.
The question I raise is, I think we need a criterion of regeneration. I think we need to regenerate Penn's Woods and the waterways. We need something that's big enough that forces us to ask, what was it like? How would this mess that we've created, do we sustain life in the midst of it?
How do we put the system back when we are just beginning to understand the
Yes.
system? Yeah, Wes, there was
And
one
on
more.
that, Owen, I think Dave, Susan, correct me, but Stroud has been doing monitoring on a really lovely old portion that we own at the Laurels, and there, over some number of years, and regardless of rain event, there is no runoff. It is an incredible sponge.
Yeah.
During
Okay.
Irene, when we had cameras out and everything, not to mention all kinds of sensors. And so when the center itself was nearly swamped by White Clay Creek, we looked at the cameras, the video cameras in the Laurels.
No runoff.
Nothing.
Wow.
Nothing.
Wow. Yes.
And they thought
Yeah.
there's got to be some problem. We looked at the sensors. Nothing.
And that's what Penn said. They built that landscape in Philadelphia, nothing. So we can
Nothing.
do it.
Yeah, no.
We just have to get there.
This wasn't built landscape. This was just
Natural
one that was
landscape.
undisturbed.
But you
Right.
can build a landscape
Yeah.
that works like a forest.
Nothing.
Yeah.
Well, this
so-
was a forest, but yes.
Yeah. So, oh, sorry.
All of Pennsylvania wasn't.
Backing up on Owen's comment.
Yeah.
So I'm not that familiar with Philadelphia's stormwater regulations. I assume that the criterion is for volume reduction in runoff.
They're good regs.
Okay. I was wondering, what about other sorts of like functional lift from restoration? Are there any other criteria that are involved there, like biodiversity, bringing back those sort of ecosystem services?
Well, interestingly, the city's named their long-term control plan for their combined sewers the Green City Clean Water Plan. And they're working towards those, that both urban rejuvenation, rejuvenating the earth, bringing back the urban, healthy urban environments and the ecosystems. We're not there yet, and it's not codified yet, but that's the long-term vision and the goal, as well as stream health.
So there's sort of like a vague...
Bigger picture of a watershed approach that brings back ecosystem functions, regenerates them, as Owen was saying. We're not there yet in the codes, in the rules, in the practice, not yet.
But fundamentally, that is the goal. That is
Yeah.
why we're trying to improve our water, is to support our resources.
Yeah.
Sure.
Is anybody working, obviously contractors are going to try to supply their customers' demand. If nobody's demanding these practices, how's there going to be any economic benefit for contractors to use these practices, to be trained in them, and get more experience?
Well, here's where we get into these issues. So you have a client like Stroud or Penn that demands them, but you have permit codes and timelines. You have ordinances that get in the way, and getting your permits to get to construction get in the way. So Penn wants to do the right thing. They got to open their plaza in time for graduation. They need a permit. So it's the interaction of these different components coming back to codes and permits really being the bottom line, I think, and because we can get to construction and practices. So we might be out of time. Are we out of time? Yeah. Thank you so much.
Thanks.
Thank you.